Hello guys, we want to go into another section of momentum. This person says a 3.0 times 3 kilogram shuttlecraft containing 50 kilogram of fuel is located in a deep space where the force of gravity can be neglected. If the fuel is consumed at a constant rate of 5 kilogram per second with a constant velocity of 150 meter per second, what is the thrust exerted on the shuttle? So thrust is like what? Like force. No, it's not like force, it's force. Thrust, we are looking for it. We are given what? The rate of mass is given as what? 5 kilogram per second. Then we are given velocity as 150 kilogram. And we are given total mass of the craft, both mass of shuttle rather as what? 3 times 10 raised to power what? 3 kilogram. And we are giving what? Mass of what? Fuel as 50 kilogram. Now what I'm going to do now is know that force is equal to mv over t. We assume it's starting from 0. So which is the same thing as thrust here. And this particular one at the beginning, which is rate of mass together. So you can write it as thrust equal to rate of mass times what? Velocity. So rate of mass times velocity. So what is rate of mass? 5 kilogram per second times what is the what do you call it? The velocity. Velocity is given to us as 150 meter per second. Sorry for that. 150 meter per second. So that is it. So we are going to multiply it and get 750 Newton. 5 times 15 is 75. Then times 10 is what? 750. Then to get what? The initial acceleration. So initial acceleration is equal to thrust divided by what? Total mass. And total mass is what? It's like mass of the shuttle plus mass of the fuel. So that means total mass thrust equal to what? Mass of fuel plus what? Mass of what? Shuttle. So what is mass of fuel? Or thrust? Thrust is 750 divided by what? Mass of what? Fuel is for 50 plus mass of shuttle is 3000. So our final answer will now be what? Let me check it to confirm it. 3050 is that one. Then 750 divided by what? 3050. So our answer is 0.245 meter per second square. That's what I want to have. You can confirm it. That's what I want to have. 0.2459. So approximately we can even say 0.25. But this is almost 4, it's up to 5. Then you add it, turn it to 0. Now that one is set already. So we have set to number 13. Let's go to number 12. I want to solve number 12 now. Now let's solve the second question. Now, he said a single stage stationary on free space has a total mass of 4 times 10 power 5 kilogram, of which 2.4 times 10 power 5 kilogram is fuel. If the velocity of the exhaust gas relative to the rocket is at 2 kilometer per hour, when the rocket engine is fired, what is the velocity of the rocket at burnout? So first of all, let's take our parameter. We are going to have a mass is equal to what? 4 times 10 power 5. That means mass, total mass. Let me put it that way. Then mass of fuel is equal to what? 2.4 times 10 power 5. Then we have mass of what? Velocity of the what? Exhaust velocity. V subscript E is equals to what? 2 kilometer per hour. Let's convert to meter per second. We are going to multiply by 1000. Then then divide by what? 3600. So this one will cancel, So we have 5/9 meter per second. Okay, what about the burnout velocity? Unknown. So the burnout velocity, we don't know it, and it has a formula of what? Minus lane, or let's say minus VE lane, the remaining what? Mass, remaining mass over the what? The total mass. Total mass. Remaining mass is calculated by removing the total mass. Burn out the velocity of the mass of the fuel from the total mass. You know why? Because during burnout, all the what? The fuel must have burn out all the what? Is fuel. All the mass of that must have been exhausted during burnout. So that means that's why we say this is exhaust velocity. So all these velocities, all this mass will have been burned out during what? During the exhaust, when it has been exhausted. Sorry, let me clean this side. So this will now be what? Okay. What is velocity of the exhaust? Now we have calculated this with 5/9 lane what? The remaining mass is calculated by 4.0 times 10 power minus 5. Is it minus 5? Okay, 5 minus what? 2.4 times 10 power 5. That's it. That's how to calculate the over total mass, 4 times 10 power 5. So we'll play with it. We'll get our burnout for velocity. So for us to get that, we would have minus 5/9 lane what? 1.6 times 10 power 5. 4 minus what? 2.4 equals 1.6 over 4 times 10 power 5. This one will cancel this. So if you take what? 1.6 divided by 4 lane, then what? 1.6 divided by 4. Close the bracket. Then multiply by what? By 5 divided by 9. I would have what? The minus sign will now what? Cancel out minus. This one put minus. So approximately will give us 0.51 meter per second. So that's what I'm going to have. Now let's solve the last question for this section. Let's solve the last question. The last question, I have 3 sub-questions under it, though very direct and straightforward. Now, what we are going to do is say what? A 1 kilogram mass, a 1 kilogram ball, that means the mass of the ball is what? 1 kg. With a speed of what? What is the speed? 4.5 meter per second. Strikes another ball. What is, let's call this one M1. Let's say M2 is what? 2 kg. With what? Stationary. That means what? U1. So let's call this one U1. And let's call this one U2. When a body is stationary, you should know that the velocity will have be for 0. So what are the balls, the speed of the balls after what? Collision. For them to say what are the speed of the ball after collision, it means that what we are going to use now is an inelastic collision. And for inelastic collision, I want to assume M1 U1 plus what? M2 U2 equal to what? M1 plus what? M2 times V. So what I want to do now, M1 is what? 1 times 4.5 plus M2 is what? 2 times what? 0 because it's at rest. Then M1 is what? 1 plus what? M2 2 times velocity. Now what I want to do now, this one will cancel out now. So we have 4.5 is equal to 3V. So how do we make the what? V the subject of formula. So V now equal to 1.5 meter per second. So that is our velocity, which is, we call them common velocity. This is what? An inelastic collision. Don't forget an inelastic collision. So let's do the last question now. Last question, or the question B is A. This A part now. Now B says what? What percentage of the initial kinetic energy do they have after the collision? Now percentage is what? The velocity, kinetic energy after is lesser than kinetic energy before. Don't forget, there are two formulas of kinetic energy. Either we write it like this, half mv square, or we write it like this, half what? P square over what? M. That is the formula for P is momentum. So if you divide what? That means kinetic energy what? After, divide by what? Kinetic energy before. If you use this formula, don't forget kinetic energy after is half what? P square over what? M1 plus M2, because they will coalesce after collision. If you divide it what? Kinetic energy with what? P square over what? M1 before, because one is stationary and one is the only one that is moving is M1, and their momentum is what? Is conserved. Don't forget, kinetic energy is not conserved during inelastic collision. So this formula will now result to M1 over M1 plus M2. This is the fraction of what? Of the energy, kinetic energy, that will remain after collision. Listen, after collision, this is the fraction, but in percentage, you have to now multiply by 100 what? Percent. So what we're going to do now is to what? Place all the value. What is our M1? M1 is 1. What is our M2? Okay, M1 again, M1 plus what? 2. Then to convert it to percentage, you multiply by what? 100. So when you do that, this 1 over 3 times 100 is what? 33%, approximately 33.3 is 33%. So that is set already. Let's go to the last one, which is what? C. Let's go to C now. Let me solve it here. Now, last one now, it says what is the total momentum after collision? Don't forget that M1 U1 equal to M1 plus M2. M1, let me put M1 U1 equal to M1 plus M2 times V. Now, this is what? Momentum before collision for this question, because one of the body is stationary, which is M2. So, momentum before collision and momentum after collision is the same. So, you can either use this one or use this one to solve it. So, if I use this one now, I would have 1 is M1 times what? I'm using this times momentum times what? U is what? U1 is 4.5 meter per second. So that means our answer will now be 4.5 kg meter per second. That will be the what? C version of this what? Of this solution, which is what? What will be the momentum before collision? Don't forget, momentum is conserved for an inelastic collision, while kinetic energy is lost. And to calculate the kinetic energy that is lost, if they ask us to calculate kinetic energy that is lost now, what I will just do is to remove this 33%, the lost in what? In kinetic energy. I will just say minus 33%, and that will give us what? 67 what? Percent. So if at all I want to calculate lost, I will just remove it from 100. So I want to leave now till when we meet again. Thank you very much for watching. Ensure you like and subscribe. Thank you.